Hi, this is Matt Baker. Last year, we released an updated, redesigned version of our evolutionary tree of life chart. We then followed this up with 4 videos in which every part of the chart was explained in detail. However, one thing that wasn't explained was how we know that the theory of evolution is true. As expected, we got a lot of comments from creationists ridiculing the chart and claiming that there is absolutely no evidence out there to back up the theory of evolution, which is simply not true. There is in fact loads of evidence, and in this video, I'm going to share some of it with you. But in doing so, my goal is not to try and convince those biblical literalists. Sadly, most of them are beyond convincing. Instead, my goal is to simply better inform the average person, who, because creationists tend to be so loud, especially in the US, often come to the conclusion that evolutionary theory is in fact standing on shaky ground, when in reality, it's not. But before we begin, let me once again point out that if you want to get a copy of the chart as a poster, you can do so right now by heading over to usefulcharts.com or by clicking the link in the description or pinned comment. First off, I need to address the word theory. In everyday speech, a theory is simply an idea that may or may not be true. However, in science, that's not what a theory is at all. For ideas that may or may not be true, scientists use the word hypothesis instead, and they reserve the word theory for ideas that have been tested over and over again and shown to be extremely reliable. So take, for example, the theory of heliocentrism, which is the idea that the Earth revolves around the Sun and not the other way around. You probably assumed that this idea is now known to be a fact. Well, it's not. It's actually still just a theory, because no one has been able to travel far enough out into space to actually observe it happening. However, in science, we don't ever say that something is just a theory, because in science, when something reaches the level of a theory, it's basically as close to fact as you're going to get. The other thing I want to clarify is what I mean by evolution. Most creationists accept what they call microevolution, which is an acknowledgement that species can and do change over time. For example, through human intervention, large dogs can be bred to become smaller dogs, and wild roses can be cultivated into complex hybrids. And even without human intervention, we know that white moths can eventually evolve to become black moths in order to better hide in their environment. But this is not what I'm talking about. What I'm talking about is what creationists call macroevolution, which is when one species ends up evolving into a totally new species, something which unfortunately we cannot directly observe, because on average it takes more than 1 million years. But it's even more than just macroevolution. What I also mean when I say evolution is the theory of common descent, which is the idea that every single species on Earth can eventually be traced back to a single common ancestor. Now, the opposite of the theory of evolution is the theory of creationism, which is not just any belief in a creator God, but specifically the idea that God created each species on Earth at pretty much the exact same time, and that all of those species have, for the most part, remained the same ever since. So according to creationists, fish were created at the same time as birds, and mammals at the same time as insects. So why am I so sure that creationism is wrong and that evolution is right? Well, I'm going to give you 6 reasons, starting with this one. The older a geologic layer is, the less diverse and less complex the fossils found within it will be. You see, over time, changes occur to the Earth's surface, and new layers of rock end up forming on top of older layers of rock. This means that, generally speaking, the deeper down you dig, the further back in time you go. If creationism were true, you'd expect to be able to find, on average, the same sorts of fossils wherever you look. But this is not what we find. For example, lions, which according to evolution appeared only recently, are never found at deeper levels. They're only found in more recent layers, such as at the La Brea tar pits. On the other hand, fish, which have been around for much longer, are found both near the top as well as down in much deeper, older layers of the earth. It would take just one discovery of a fossil that goes against this pattern to disprove the entire theory of evolution. So, for example, if any fossilized mammal were ever to be found at a very deep level where previously only Cambrian fossils had been found, then boom, the whole theory would crumble. But that has never happened because whenever fossils are found, they always adhere to a very clear pattern. Lots of different types near the top, including the most complex forms of life, fewer and more simpler forms as you go down. So if you were to chart out all of the 250,000 plus fossil species found to date, according to how old each one is, you'd end up with a chart that looked like, well, something like this. Okay, reason number 2. All animals share the same basic anatomy, even when it doesn't make sense. To put it another way, whether we're talking about reptile species, bird species, mammal species, or even humans, while each species may look very different, each one is actually just a variation on the same basic body plan. One that has 4 limbs and a head, with 2 ears, 2 eyes, 2 nostrils, and just 1 mouth. This indicates that all animals evolved from just one original species, and then went in different directions from there. You'd think that if a creator had designed each species from scratch, there'd be a bit more variety in terms of body plans. Like why no turtles with 6 legs? Or mammals with 4 eyes? Let's look at things in even more detail. Take for example our arms. As I mentioned in episode 2, humans have a single bone in our upper arm called the humerus, followed by 2 bones in our lower arm called the radius and ulna. These are then followed in our hands by carpals, 5 metacarpals, and 5 phalanges. Well, every single reptile, bird, and mammal, even bats and whales, have this exact same set of bones, just in different proportions. Again, this indicates that we all evolved from just one original species that had this arrangement. We can do the same sort of comparisons with insects and with plants, and we can even combine all the various ancestor species together to get even older ancestor species. In the end, we'd end up with, yet again, something like this. Now, before you argue, well, God just used designs for basic body plans that work really well, and that's why we see them repeated. Well, let me remind you of the second half of point number 2. All animals share the same basic anatomy, even when it doesn't make sense. A good example of something not making sense is the laryngeal nerve, which goes from the brain to the throat and is an aspect of the general animal body plan that we all share. There's a bit of a design flaw in that the laryngeal nerve loops around the aortic arch instead of going straight to the larynx, which would have been easier. For most animals, this isn't much of a problem. However, for giraffes, it creates a rather ridiculous scenario in which that nerve has to go all the way down the long neck, loop around the arch, and then go all the way back up again. Doesn't seem like something a designer would do, but it does make sense if giraffe necks simply evolved to get longer over time. An example in humans is our faulty sinuses. If you want to learn more about them, I suggest you check out this video by Stefan Milo, which I'll link to in the description. Now, all this talk of faulty design brings me to reason number 3. Many animals have body parts that they no longer need. Take, for example, dolphins and whales. Unlike most mammals, dolphins and whales have only 2 limbs, their fins, instead of the usual 4. However, if you look at their skeletons, you'll find that they actually have bones for back limbs that they don't use. In fact, those bones are located entirely inside their bodies. This is because once upon a time, the ancestor of all dolphins and whales was a 4-legged land creature. But over thousands of years, as that creature spent more and more time in the water, it no longer needed its back limbs, and therefore they just kind of whittled away. Even humans have features like this, which are known as vestigial structures. My favorite example is that of goosebumps. In most mammals, goosebumps serve the purpose of making an animal's hair stand up, either when it's scared, so that it looks bigger, or when it's cold, so that it can warm up. Humans still get goosebumps when they're scared or cold, but because we no longer have much hair, they no longer do anything, except make our skin look like we've got a bunch of little pimples. All right, moving on. One of the things that makes evolution so hard to accept is that it takes millions of years, and therefore we can't see it happening in real time. I mean, even I'll admit, the thought of a single cell evolving all the way to a human seems pretty crazy. But here's the thing. We can, in fact, see a single cell evolve into a human in just 9 months. It happens every time a zygote grows to become a baby. So let me now give you reason number 4. As fetuses grow, they acquire features in the exact same order that they are predicted to have been acquired through evolution. The result is that, at certain stages, all animal fetuses look pretty much the same. Then they go in different directions, just like they did in evolutionary history. In order to better understand the significance of this, imagine 5 different Lego sets, all of which start out with the exact same set of instructions. But then 4 of them get an additional set of instructions, and 1 doesn't. Next, imagine that of the remaining 4, 2 get a third set, called Part 3A, and the other 2 get Part 3B. Finally, imagine that those same 4 all get a 4th and final set of instructions, but that this time each set is unique. Now, if a creator was designing 5 different Lego sets, they could do it this way, but they wouldn't have to. If they wanted to, they could simply make 5 different Lego sets, all with different pieces and with different instructions. So even if you believe that God created every species at the exact same time, you can't deny that God did it in a way that made it seem like some species were designed off the plans of others. As if God was experimenting, which is weird because God is supposed to be perfect, and therefore God shouldn't have to use trial and error. So once again, if we put all these step-by-step building stages for each species together and then sorted them out based on what built upon what, well, you guessed it, it would look something like this. So either evolution is true or God went out of the way, and I mean really out of the way, to make it look like evolution is true, going as far as to make sure that only the fossils of really simple life forms ended up in the deepest layers of the earth. Okay, for my last 2 points, I'm going to get a bit more technical. As you probably know, the actual instructions for living things are stored in a structure called DNA. Well, a single strand of DNA is called a chromosome, and most animals have several chromosomes, a full set of which is stored in every cell in their bodies. The number of chromosomes a species has varies quite a bit, from this ant, which has just 1, to this butterfly, which has about 450. But keep in mind that the number of chromosomes doesn't indicate how old a species is in terms of evolutionary history. This is because chromosomes can both split and fuse, and they do so often, although by often I mean every few million years or so. And because they split and fuse so often, and can do so in various different ways, some chromosomes end up being really long, and others end up being really short. Now, how is this useful in terms of providing evidence for evolution? Well, even though chromosomes can vary quite a bit, you'd expect that 2 species that were very closely related would have very similar chromosomes, both in terms of number and size. So to test this, let's take humans. We have 46 chromosomes, or 2 sets of 23. According to evolution, our closest ancestor is the chimpanzee. So how many chromosomes do chimpanzees have? Well, they have 48, or 2 sets of 24, as do gorillas and orangutans. But let's place one of their sets of 24 next to one of our sets of 23. Take note that on this chart, H stands for human and C stands for chimpanzee. Well, what do you know? Most of the chromosomes match almost perfectly. The only one that doesn't is our chromosome number 2. But in that case, there are 2 chimpanzee chromosomes that when put together match it almost perfectly. The most likely explanation for this is that our common ancestor, like most great apes today, had 2 sets of 24 chromosomes. But then at some point in the branch that led to humans, 2 chromosomes fused to become 1, reducing our total to 2 sets of 23. So my reason number 5 is, just like a DNA test can determine who your closest human relatives are, comparing broad similarities in DNA can determine who our closest animal relatives are. Now, before I move on, let me clear up a common misconception that people have about evolution. Most people seem to think that evolution says that humans evolved from chimpanzees, but it doesn't. What evolution says is that both humans and chimps evolved from a common ancestor, one that was neither a human nor a chimp. Although I'll admit to the human eye that common ancestor looks more like a chimp than it does a human. Another thing that creationists like to say is, if one species can evolve into another species, take, for example, a tiger and an elephant, how come we've never found a fossil of a half-tiger, half-elephant species? Again, this boils down to a misunderstanding of how evolution works. According to evolution, a tiger will never evolve into an elephant, and an elephant will never evolve into a tiger. However, if we go back far enough in time, we can find a common ancestor that was neither a tiger nor an elephant. You see, we can move forward along the branches of the evolutionary tree, and we can even make new branches. But one thing we can never do is jump from one branch to another, or combine 2 branches to make a chimera. Okay, my last point builds on point number 5, but gets even more technical. It has to do with viruses. Viruses differ from living things in that they cannot survive on their own. In order to replicate, they need to infect a living host. Well, sometimes a piece of a virus's DNA or RNA actually gets inserted into the host's DNA, and then from there continues to get copied to future generations. Whenever this happens, the new sequence is called an endogenous retrovirus, or ERV. Usually the ERV doesn't cause any harm. It's basically just the equivalent of the virus leaving a bit of graffiti saying, "I was here." Now, don't start freaking out over the thought of a virus being able to change your DNA. From the standpoint of a human lifespan, ERV events are extremely rare. But over hundreds of millions of years, they do add up. So much so that it is estimated that around 8% of the human genome is basically viral graffiti. Another way to look at it is to see these ERVs as being sort of like fossils, but in our DNA. Each one is a record of something that happened a very long time ago. Species that are closely related to us, such as chimpanzees, have virtually the exact same ERVs as we do, in the exact same places, whereas species that are less related have less ERVs in common. Again, we can use ERVs to map out the past and to find out which species are more related to which species, and even build a tree based on our findings that will look, one last time, like this. So reason number 6 is endogenous retroviruses serve as markers for when changes in DNA occurred, and thus can be used to map out the tree of life. So, whether we chart out species by where their fossils are found, or by how similar their body plans are, or by how much DNA they share in common, everything leads to the same conclusion. There's a pattern to life on Earth that can be best described as looking like a tree, in which, from the top down, each branch eventually merges with other branches, which then merge with other branches, and so on, until we get to one single trunk. Going the other way, from the bottom up, life started small, but over time, mutations that turned out to be useful led to permanent changes in some species. And as the process repeated itself, not only did more and more species come to exist, but more and more categories of species, hence all the branches of the tree. Again, I'll admit it's a pretty difficult thing to wrap one's mind around. But that's because our human brain did not evolve to think in terms of hundreds of millions of years. Logically, we can understand what the number 100 million means, but it's really hard for us to truly grasp just how long 100 million years really is, and how, given that much time, how a sequence of tiny little changes can in fact add up to a massive amount of change by the end. Now, before I go, I want to say two things. First, keep in mind that accepting evolution does not mean giving up one's belief in God. For some people it does, but for many others it does not. That's because accepting evolution and believing in God can go hand in hand. Secondly, understanding evolution takes time. If you're on the fence, this one video is probably not going to be enough to convince you. Therefore, I'm going to leave you with a few book recommendations that will help you explore further. If you're going to read just one book, it should be either Why Evolution is True by Jerry Coyne or The Greatest Show on Earth by Richard Dawkins. Both cover a lot of the same ground that I covered in this video, but in much greater detail. Another great book is Your Inner Fish by Neil Shubin. It demonstrates how our own bodies serve as a testament to all the various changes that have occurred throughout evolutionary history. Now, for those of you who are religious and might be interested in reading something from an author who shares that in common with you, I'll give two final recommendations: Finding Darwin's God by Kenneth Miller and Life's Solution: Inevitable Humans in a Lonely Universe by Simon Conway Morris. Okay, if you've enjoyed this 5-part series, you'll be happy to know that in about a month from now, I'll be releasing the full series as a single video for easier sharing. So keep an eye out for that. Thanks for watching.